Imagine a fleet of space jets exploring space, not having to return to Earth's orbit to refuel.
What we're trying to do at TransAstra is to build the transcontinental railroad of space.
Think it's the stuff of science fiction in Hollywood? This man thinks it's our future.
We believe that optical mining of asteroids can be a technological breakthrough that turns thousands of asteroids into refueling stations for spacecraft. Refueling stations for NASA astronauts exploring the asteroids, exploring the moon, going to Mars. Refueling stations for private sector business, delivering satellites to geostationary orbit.
But first, Joel Sercel has to see if he can actually extract vapors from an asteroid. In other words, he's trying to get water from a stone.
Here we are at the White Sands Missile Range at their solar furnace facility. What we're going to be doing is sunlight from the sun is going to bounce off that giant mirror back there, and it sends the rays through this giant Venetian blind, and it'll go into a parabolic reflector and focus it down into a little 4-inch circle. Now we will have asteroid simulants inside of a vacuum chamber. The sunlight will hit the simulant, and when it does, it'll be so intense that it'll fracture, break the surface of the simulant, and drive vapors out of it, water and carbon dioxide. And as those vapors are driven out, it'll excavate or dig holes in the asteroid simulant. So in theory, we know exactly how to mine water from an asteroid. The question is, in practice, can we make that happen? Let me tell you how I'm feeling about getting started with these tests. In a word, terrified. Sometimes I feel like David up against Goliath. We'll see if we can mine some water out of this. So, wish us luck. So this is the experimenter's room and the control center for the solar furnace here at White Sands. So basically, the staff from White Sands sits at this workstation and uses this computer to control the facility, controls the big heliostat that tracks the sun, controls those louvers that let the light through, and they control a big shutter that they can open and close to let the radiation into the experiment area. This is the aperture stop that lets just this much sunlight through.
With the simulated asteroid in the vacuum, Joel and his team let the light in.
3, 2, 1, open. It's 500 and something degrees. It just changes between what units? Fahrenheit. Holy cow.
Okay, let's shut it down.
Shut it down.
And I think we melted the O-ring. You can tell exactly where the light was coming in. It's right there. So what happens is, as a highly concentrated light comes in, it breaks the surface of the material. And it heats the material. When it heats up, it lets out water vapor and carbon dioxide. The process of breaking the surface and digging holes is called spalling. As you can see, we dug a big hole. And the spall process released debris, which is all collected inside the tank.
The heat was intense enough to break up the simulated asteroid, but the big question remains to be answered.
I'm going to open this. Maybe we trapped some liquid from the experiment. I'm kind of on pins and needles here. There's something there. There's moisture that was captured, but not enough to transfer to a flask. Not what we were hoping for, but not a disaster.
Today's experiment didn't go exactly as planned, but for Joel, the dream of asteroid mining is alive and well.
We think that this could be a very important transition for mankind as we move from being a purely terrestrial species to being a spacefaring species where our industries go in space, keeping the planet clean for everybody. At that point, it will be possible for people to actually go and colonize and settle space. That's our vision.